Thank you very much, Vitaly. It's lovely to be here, and that was a really brilliant talk by Michelle, so full of really practical, actionable insights. So I'm going to step back a moment to the bigger picture. And the bigger picture is not good, as we are aware. We have crossed 6 of the 9 boundaries which make life habitable on this planet. So it's global heating or global boiling we're in at the moment. But we also have biodiversity loss. We have an absolute crisis in biodiversity loss. We have an absolute crisis in soil loss. We have a freshwater loss crisis. We have a nitrogen and phosphorus crisis from crops and farming. And we have plastic pollution, and we are rapidly approaching ocean acidification. So all the red lights are going on around the planet, and just focusing on carbon often hides the problems in the other areas. In fact, sometimes making it better for carbon makes it worse for biodiversity, or makes it worse for soil, or makes it worse for fresh water, as I'll explain later. And we need to approach the problem looking at all the multiple crises, not just the single crisis. And technology and digital contributes to most of these areas. It contributes negatively to global warming. It contributes negatively to biodiversity loss, to soil loss, to freshwater loss, and to plastic pollution. So the story of digital is intensely physical and intensely material, even though the digital industry has done an amazing job of greenwashing to pretend that we are ethereal, everything is in the cloud. There's an acceleration, an extraordinary, scary acceleration happening in relation to the crossing of these boundaries, which basically make life that we can live it. If we keep going at the pace we are going, it's difficult to see how civilization, as we understand it today, will survive for another 50 to 100 years. That's how serious it is. And I don't think we realize, most of us, quite how serious it is. This is in 15 years. So in 2009, we had crossed 3 of life's boundaries. By 2015, it was at 5. By 2023, it was at 6, and we were rapidly approaching the 7th. This is just in 15 years. I mean, we've been around as a species for hundreds of thousands of years, and most of the damage we have done in the last 50 years. 75% of all the CO2 damage that humans have been done since 1970. And that also runs parallel with the growth of the technology industry. Materials is where it's at. If we want to understand impact, whether it's in digital or in any other area, it's our use of materials. We consume far too much materials. And this so-called green transition, this idea, this lie that we're telling ourselves, if we electrify everything, we can still keep consuming. That is one big monumental lie. We need to radically reduce our consumption if we have to have any hope of survival of this civilization over the next 50 to 100 years. Our politicians are lying to us. Of course, big tech is lying to us because it makes money out of destroying the environment, and all the other big brands are lying to us as well because they want us to keep consuming, because unfortunately there is a lot of money to be made out of destroying the environment. But all of our technological world, all of our green tech so-called transition requires materials, and copper is one of those materials, one of those so-called critical materials. So back in 1900, if you were mining for copper, the average ore grade quality was 4%, which meant that of 100 kgs of rock that you'd mine or soil that you'd mine, about 4 of those kgs would be actually copper. So it was about 4% ore grade quality. By 1950, it was down to 2%. By 2005, it was 0.7%. By 2017, 0.6%. And by it's estimated by 2050, it'll be 0.3 of 1%. So what that means, and this is the whole story of mining to build our world for all the materials, is that most of the materials are not disappearing. It's not as if one day we have iron ore and the next day we don't. They are just dissipating. They are becoming harder and harder to get good quality quantities of them in the same place. So what is the implication of this? Well, waste per ton of copper. So if you were getting 1 ton of copper in 1900, you would create 25 ton of waste. But if you want 1 ton of copper in 2023, you will be creating 190 tons of waste. So in the mining industry in 1970, we were creating about 25 billion tons of waste. By 2020, we were creating 100 billion tons of waste. Now, Mount Everest has a mass of 175 billion tons. The wonderful people in big tech tell us that if we electrify everything and do the great green transition, unfortunately, we will have to mine by 2050 170 billion tons of waste. So we will be mining a Mount Everest every single year by 2050 to get to our so-called green transition. This is not sustainable. This world cannot continue no matter how many ways we pretend it actually can. And we need radical changes to occur really, really quickly. So what we have is a decrease in ore grade quality of the vast majority of metals that we are mining. So they're not totally disappearing, they're just dissipating. But the demand on them, we mined about 3.5 million tons of copper in 1959. It was 20.5 million by 2018, 26 by 2021, 36 by 2030, and some estimates that we need to be mining 80 million tons by 2050. So there's this absolute explosion of production and consumption. We don't have an energy production problem. We have an energy consumption problem. We have a material consumption problem. So waste, because waste is the hidden story of our world. In 1900, let's imagine we started the mining of copper. Year zero was 1900. It took us 108 years to get to 1 Mount Everest of waste, which is 175 billion tons of waste connected with copper mining. So it took us 108 years. How many years to get to 2 Mount Everest? 14 years. So from 2008 to 2022, 2 Mount Everest. And you see this incredible growth. Basically, by 2050, if everything goes as planned for big tech, we will be creating half a Mount Everest of waste just to mine copper, just to mine one of the so-called minerals. Technology is the most materially intense industry that has ever existed. In your smartphone, there is somewhere between 60 and 70 materials, right? 15 or 20 years ago, there was only 10 materials in the process. Electronics are extraordinarily materially intense. We have done an amazing job of telling the world that it's the cloud. Well, the cloud in 2022 was 70 million servers, and this year it's probably more like 100 million servers, right? Each one of those servers caused between 1 and 2 ton of CO2 to manufacture. So most of the damage occurs during the manufacturing and mining process of electronics, a story that we are never told about, a story that we never tell. We just tell the story about energy during use, and we can manipulate that in a really interesting way. In fact, the data centers are going around the world saying, look at us, look at how energy efficient we are. Do you know how they became so energy efficient? Well, one of the ways was by using massive quantities of water. So they affect fresh water use. So they get this wonderful energy story by destroying fresh water. But another way was by absolutely running through servers at an extraordinary pace, so creating massive quantities of server waste. So it's estimated out of 70 million servers, about 20 million of them will become waste on a yearly basis, and that most of those will actually be destroyed. These servers, which a couple of years earlier caused between 1 and 2 ton of CO2, between 5 and 10 ton of toxic mining waste, this is each server. This is each server and hundreds of thousands of litres of wastewater to manufacture. So digital is extraordinarily material intense, so we must look at the devices first and foremost if we want to do something about making digital in any way better for the climate. What is often driving the devices is the data. We have a data crisis, right? Back in 2010, we were creating 2 zettabytes of data a day. Right? 1 zettabyte of data, if you were to print it out, would require 20 trillion trees. That's just 1 zettabyte of data. So there are only 3.5 trillion trees on the planet. So that gives you some sense of the quantity of data. And this is every year, 180 zettabytes by 2025, 2,000 zettabytes to store, and we only store about 10% of what we produce on a yearly basis. But to store about 300 or 400 zettabytes of data, you'd need over 1 billion servers. 1 billion servers to store what we'd be producing in 2035. This is not sustainable. Data growth is not sustainable. It's growing at 28% annual growth a year, and 90% of it, at least 90% of it, is crap. At least 90% of data is not accessed 3 months after it is first stored. So we need to start asking ourselves, why are we creating these things? Not just looking after the fact. Why is the need exists for this? And how can we create less things, create less data in the actual environment? So our smartphones on average cause about 60 kg of CO2 to manufacture and about 5 kg to use them on a yearly basis. It's estimated about 14,000 litres of water. 14,000 litres of water to manufacture 1 smartphone, right? And 300 kgs of mining waste in the process. Our laptops cause 300 kgs of CO2 to manufacture. They cause 1.2 ton of toxic mining waste that destroys rivers, destroys soil, destroys the air, mainly in poor countries. So we don't need to worry about it. It's only happening in South America and Africa. So that's okay, I suppose, because it's not affecting the rich people. That's the other story of our wonderful digital world. We have outsourced nearly all the harms to the mining, to the poor countries, the manufacturing to Asia, and then the dirty old e-waste. What do we do with that? We dump it in Africa because, of course, Africa is a great dumping ground for the luxury goods of Europeans and North Americans. We have a wonderful model of lying to ourselves in the West and the global North. Waste is everywhere in everything that we do, as Vitaly alluded to earlier. Waste in the way we develop code, waste in our websites, waste in our emails, because we're lazy and we always go for convenience. We always want the easy life rather than having to do a little bit of hard work to clean up after ourselves. How many of us ever clean up after ourselves, the code or the content or the work groups that we create? How many of us ever go back and clean up the crap that we left behind us? Because we don't care, because it's cheap to create, it's cheap to store, and of course it's all in the cloud, isn't it? It doesn't really have any impact. I calculated that email spam and unopened attachments and unread emails, we would need to plant 32 billion trees every single year just to deal with the pollution connected with the spam email and the unopened attachments. So all of this has an incredible impact just because you don't see it happening. Do you ever look at your phone and think, here are 70 materials? Do you ever think about what goes into your phone and then what happens to that phone? Because they're not designed to be recycled. So if there's one thing we can do, the single most important thing we can do is to hold on to our materials as long as possible. Hold on to our phones as long as possible. Hold on to our laptops as long as possible. When we're buying phones or laptops, buy phones that are repairable. Look for Fairphone, a great Dutch company, or Framework Computer. Go with phones and laptops that are modular and repairable, and hold on to them as long as we possibly can, because the vast majority of the damage that digital does occurs during the manufacturing or the e-waste phase. So the longer we can keep the materials in use, the more we can mitigate the damage. We can never get rid of the damage, but we can reduce the damage. A lot of the space when we're dealing in the web, we cannot create web pages, not create content. That would be a wonderful thing to do. Make decisions about what I'm not going to do today, what decisions I'm not going to make in the process. And even if we can't do that, look at the sites that we've created and look at how we can delete 90% of them. Because I've been working on website design since 1995, and in the vast majority of situations, when we deleted 90% of the website, everything worked better. This was a long-term project I did with the Internal Revenue Service, and the page on the left was their business page, and then they moved to a top task model, just focusing on 4 major tasks. Everything was better, reduced support calls, everything worked better with less content, better managed, simpler pages, less bloat. Cut the crap in every single way, whether it's in content, whether it's in code. Michelle gave a ton of great practical advice there earlier. I just want to give you a little bit of model of thinking about making a decision to actually do something or not do something in digital. Let's say somebody comes to you and say, I want to create an article for the website and it's going to be 1,000 words. Well, I calculated that on average, 1,000 words of content takes around 20 hours of effort in the writing, in the ideation, in the editing, in the approval, in the publishing, in the creating of the page. So let's say about 20 hours of work goes into it. All of this work happens on a device, on a machine, on a laptop. So that's an assumption, right? Let's assume the page is overall 5 megabytes. And let's assume that it's read once and that the reading time is 4 minutes. So what is the total? And I'm just looking at CO2. I'm not dealing with the water. I'm not dealing with the soil. I'm not dealing with all the other impacts. But what is the total impact if we allocate the whole life, the machine impact, the manufacturing impact of these laptops, etc.? Well, It's about 1800, 1.8 kg of the damage occurs in the creation process. It's those 20 hours on laptops. I created a model which allocated across the entire life of the actual laptop. The streaming of that, the movement of that up to the server, very, very little, because it's only read once, and the use of it about 8 grams, because let's assume it's also read on a laptop. So that 4 minutes is about 8 grams of CO2 in its total impact. The storage of it is about, let's say it's stored for a year. That's about 13 grams in an actual data center. Somewhere in the region of these numbers. Okay, that gives us basic frame. So you're saying, well, that's about 2 kg of CO2. Do we really need to create this 1,000 words? And this is 1,000 words, right? That's read once. Let's assume it's read 10,000 times. What happens? Well, create doesn't change. It still took 20 hours. It's 1.8 kg. Streaming jumps a bit, but streaming is relatively speaking energy efficient. The story really isn't there, but the user's device, that's where the story is. If you've got a big website, most of your damage is on the user's device, because that's where most of the activity is happening. So now we've got 60 kg over on the user's device, all these 10,000 devices spending 4 minutes, and storage about 0.3. So that's about 61.8, about 62 kg. So let's say you've got a great editor like Vitaly who comes to you and say, let's really work on this article and bring it down to 500 words, right? So that it'll be clear and easier to read and faster to read in the process. So let's say we do that. So we've doubled the creation times. So Vitaly give you 20 more hours to do that, because it's harder to write 500 words than to write 1,000 words. So now the creation cost is 3.6 kg, streaming the same, but now the use has gone down to 30 kg. So the total cost, the total damage is 33. So if you've got a large website, most of your impact is on your user's device. So Michelle talked earlier, she alluded to usability. That's where most of the damage, because basically it only taken a couple of seconds for that page to download. The person is often spending minutes searching for the content or trying to understand it and actually reading it. Let's look at the scenario where there's bad usability. So it takes 2 minutes for it to find, right, and 4 minutes for it to read. This is the sustainability case for usability. We're still at 1.8, we're still at the stream, but now we're up at 90 kg because we're adding another 2 minutes per user. So now we're up at 92 kg for the actual waste. So most of the damage or most of the benefit occurs for particularly large websites where you've got lots of users in the user environment. If we truly want to understand our impact, we must understand our impact in the user's device. And that's where things like JavaScript can be so negative. JavaScript is not just bad, it is discriminatory for people who have got older phones. They may not even be able to use it, or it may take so long to compile that, it's 30, 40 seconds on their phone. So it's essentially unusable. Large, complex websites are discriminatory. They are horrible for the environment, and they are totally negative for society in multiple ways. But us developers and web designers, we never see that because we've got all the latest devices and the big screens, and we live in a wonderful world of the cloud and deniability and invisibility and interiority. It's all the other people who have to live with the consequences of what we create. A basic website without any content. I calculated, or working with a wonderful Piano D, an Italian web design agency, we calculated that you'd have to plant 10 trees for designing just one basic website. So one basic website was about 100 kg of design CO2 in the entire process. That's about 10 trees. A typical tree can sequester about 10 kgs a year. Ask yourself, as a designer in digital, how can we slow people down? Digital drives overconsumption. That's even more damaging than the materials. Google is an advertising agency. Facebook is an advertising agency. Apple is planned obsolescence. Amazon is a discounter. All the Netflix is basically trying to get you addicted to watching. It's trying to get you to be a binge watcher. So most of the damage that occurs in the digital ecosystem is driving overconsumption. And as a designer, if we could go a different way to creating a slow web, slowing people down. Think about delivery. It's all about speed. It's all about getting it there in the next hour. Well, if we are delivering fast, the truck will be less full, bad for the environment. We need more trucks. They'll be faster driving, more pollution, dangerous, more stress, bad for the neighborhood. The driver will be more stressed. Far more injuries are occurring for delivery workers and warehouse workers in e-commerce than in any other industry. Modern Amazon warehouses are like slavery, and Amazon drivers are being slave-driven to get our packages there within an hour. Double the warehouse injuries are occurring in e-commerce warehouses. You'll have to have larger stock levels, and you will, if you're particularly doing food, you'll have more food waste in the process. So if we could create mechanisms to encourage and explain to our customers, can you wait a couple of days? Because the vast majority of times you can wait. We don't need these things within an hour. We are destroying the planet for crazy, crazy, fast convenience. We must slow down. How can we design for the slow web to slow people down and to make people think? Michelle talked about all these issues. I'm not going to go into them, about the various impacts as we go through, about video, how extraordinarily damaging video is. And for the vast majority of communication, we don't need video at all in the process. So video and images being particularly damaging, and JavaScript, it's a low percentage, but it has a much bigger impact when it arrives on the user's device because it calls in a lot of processing. The growth of photo is absolutely extraordinary. We took more photos last year than we took in the entire 20th century. By 2020, we had taken 13 trillion photos. Right, and the vast majority of those photos were taken in the last 10 years or so. We are now storing 10 trillion photos in the cloud, and the vast majority of those photos will never, ever, ever be accessed again. We are the generation of waste. We are wasting our environment for what? For easy convenience. We have to slow down and stop taking so many images, stop creating so much content. It has an extraordinary negative and growing impact on our environment. And photo resolution, everything is getting bigger. Artificial intelligence queries are 10 to 30 times more impactful than basic search queries. Everything in digital is asking more and more materials, more and more energy, more and more water. And we can't even see 64, these 8x images on our smartphones or our laptops. We can't even see these 4K images or these 8K images. It's extraordinary why we're doing this sort of stuff, and why we're one 8K video of 1 minute can be 6 600 megabytes. 1 minute of 8K video can be 600 megabytes, and we can't even see the difference. So really asking, why do we need this in this resolution? I'm always moving to the lightest possible option. So I'm going to leave you with these, and it's a kind of a model of thinking of we can never have a green digital. We can just have a less damaging digital. It can never be green because it's extraordinarily material intense. You know, there's two apples. One of them is organic and the other is material and toxic. And it'll always be material and toxic, right? So I did an experiment, a small experiment with 1,000 words of text, and I saved it as a text file. It was 6 KB. So text is the least damaging way to use digital, and by far the least damaging form of communication is a text message. So if you still text, that's by far the least damaging way to communicate using digital. The next best way is well-optimized HTML. HTML is the least damaging of all the choices that we actually have. So we should always go to HTML and say, can we do this in HTML? Always go back to HTML if at all possible. If we save this as a Word document, it would be 16 kilobytes. If it was badly optimized HTML, it could be 50 megabytes. And PDFs, terrible. I hope nobody out there is using PDFs. PDFs are just a quick and dirty way to pretend that we're digital, but it's really just transferring all the worst habits of print into the digital realm. So we can see a bit of a scale there. So, but once we move to images, we're up into a different level. So 1,000 words is about 2 A4 pages. So I created 2 images, each one of them the size of an A4 page. And these were the basic weights. And you can see, you know, we're up to about a megabyte. So if we optimize properly in images, we can save massive. But as Michelle said, the vast majority of images are crap. They add nothing to the meaning, nothing to the usefulness of the environment. So let's start questioning, why do we need this? Why do we need this? Why are we creating this? Let's stop it before it gets created in the process. We go to audio. Reading 1,000 words of text is about 4 minutes of audio. Now we're up into 8 megabytes, and WAV is 66 megabytes in the process, 11,000. So we're going to video, right? Up at 8K video at 1,000 words of text, the equivalent 4-minute 8K video. That's 400,000 times more damaging than the 1,000 words of text in basically HTML or a Word file. So our choices matter. Always go for the lightest, least damaging choice. And the lightest, least damaging choice of all is to not create. Thank you very much for listening.
Roger, I've been sitting there just being like really mind blown by all the facts and the actual impact we have here in front of us now. That's of course a very scary picture to look at as developers, as designers, as engineers. One thing that I really like, that kind of really stuck with me, and I think we maybe should have kind of a little bit more kind of conversations about that, is this idea of encouraging people to wait or slow down, right? Because of sustainability, or for sustainability, I should rather say. And this is also something that Amanda, I think, brought up in the chat as well. This is really interesting. I'm wondering, like, as we've been working through different things together, one of the things that we actually encountered was related to video was that one thing that is often missing, and like if you look at YouTube, this is always missing. There is no option to just turn on audio only. Because if you think about, let's say, live stream, sometimes if you're looking, I don't know, if you're watching a concert or if you are watching a live stream or anything, sometimes it's happening in the background. You don't even watch video. And by default, it might be in 4K or whatever, or full HD, because you happen to be on a good connection, right? So this idea of kind of slowing down, this I think is very reasonable. I'm wondering, Jerry, where do you think most impact? So if we wanted, let's say, to to do something at scale, to really make a significant impact, where do we start? Now, those kind of patterns can help, but like, where would you suggest to start?
Well, you know, you've put your finger on to some degree, Italy, there about slowing down. But even I talked to a professional photographer there a while back, and he said, you know, wait for the right moment to take the photo. Train you rather than thinking, oh, click, 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 click.
Right.
Just wait. Train yourself to wait. Not every moment is photographable. You know, not because you're never going to go back to them. So he said it took him years to try and wait. But he says, even then, I'll still take 20 or 30 or 40, maybe in a shoot, I'll take 100 photographs. But what I will do immediately after I've done that is I'll review immediately, and I'll generally delete about 80 of them. So often the best time to clean up is very soon after that actual initial creation splurge in the process. So if we're we've created a whole bunch of prototypes or stuff like that, we can decide that's not going to work, that's not going to work, that's not going to work. And instead of just leaving it there stored in the cloud, get rid of it in the process. So get into the habits of not always feeling that we must create something, and that sometimes a conversation is enough. People have terrible bad opinions about meetings, and bad meetings are bad, but meetings are much better than 20 people going off and just creating random stuff that gets stored and is there 10 years later in the process. So challenging each other to say, do we really need this? Do we really need this? Is this really necessary? Why are we collecting this data? No, Vitaly, you don't collect, data on visitors like most people do in the sites. Most web analytics data, nobody looks at it. And even the people who look at it, they don't understand it, but they keep collecting it, even though they don't understand it, even though they don't act on it. Only 1 out of 100 organizations I have worked with have actually acted properly on their web analytics. Yet everyone keeps it and everyone stores it. And if you tell them to delete it, they know, no, we can't. How could we possibly? Well, what? You don't use it. It's no good. So why do you have it? We need more people within organizations asking difficult questions about the data, because we create and store far too much data that we never, ever go back to.